Matter in our surroundings. Anything which occupies space and has mass is called matter. Air and water, hydrogen and oxygen, sugar and sand, iron and wood, copper and coal, ice and alcohol, milk and oil are all different kinds of matter because all of them occupy space and mass. If we look around us, we can see a large number of things of different shapes, sizes, and textures. Many of these things are used by us in our everyday life. For example, we eat food, drink water, breathe in air, and wear clothes. We use table and chair for studying and bed for sleeping. Matter can be classified in a number of ways. Ancient Indian philosophers said that all the matter, living or non-living, was made up of 5 basic elements: air, earth, fire, sky, and water. Matter is made of particles. Everything around us is made of tiny particles. A body is made of particles. Matter. A chair is made of particles. The diffusion of potassium permanganate. The number of particles in everything is, however, very, very large. For example, a small raindrop contains about 10 to the power 21 particles of water in it. The particles which make up matter are so small that we cannot see them even with a high-power microscope. Even without seeing them, we have certain evidence which tells us that all the things is made of tiny particles. We will now give some of the evidence which clearly shows that all the matter is made up of tiny particles. This evidence also shows that the particles which make up the matter are constantly moving. Please note that the particles which make up matter are atoms or molecules.
Characteristics of particles of matter. Introduction. Characteristics of particles of matter. The important characteristics of particles of matter are the following. Number 1. The particles of matter are very, very small. Number 2. The particles of matter have spaces between them. Number 3. The particles of matter are constantly moving. And number 4. The particles of matter attract each other. The particles of matter are very, very small. Now, we discuss these properties in detail. So the first property is that the particles of matter are very, very small. The very, very small size of the particles of matter can be shown by performing the following experiment by using potassium permanganate and water. Potassium permanganate is a kind of matter. We take 2 or 3 small crystals of potassium permanganate and dissolve it in 100 milliliters of water in a beaker. We will get a deep purple colored solution of potassium permanganate in water. Take 10 ml of deep purple solution of potassium permanganate from the first beaker and mix it with 90 ml of water present in the second beaker to dilute it. Due to this dilution, the color of potassium in the second beaker become a bit lighter. Now take 10 ml of potassium permanganate solution from the second beaker and mix it with 90 ml of water present in the third beaker to dilute it further. The color of solution will become still lighter. We keep on diluting the permanganate solution like this a number of times. In this way, we get a very dilute solution of potassium permanganate in water, but the water is still colored. This experiment shows that just 2 or 3 tiny crystals of potassium permanganate can impart color to a large volume of water. From this observation, we conclude that each potassium permanganate crystal itself must be made up of millions of small particles which keep on spreading and imparting color to more and more of water. The particles of matter have spaces between them. The spaces between the particles of matter can be shown by performing the following experiment by using water and sugar. We take about 100 ml of water in a beaker. Mark the level of water in the beaker with a marking pen. Also take 50 grams of sugar Now add 50 grams of sugar in water in the beaker. Dissolve the sugar by stirring it with a glass rod. When all the sugar has dissolved, we get a sugar solution. Let us look at the level of sugar solution in the beaker. We will find that the level of sugar solution in the beaker is at the same mark where water level was initially in the beaker. This means that even after dissolving 50 grams of sugar in 100 ml of water, the volume has not increased. This means that the particles of matter have spaces between them. The particles of matter are constantly moving. The best evidence that particles of matter are constantly moving comes from the studies of diffusion and Brownian motion. A. When we light an incense stick in one corner of a room, its fragrance spreads in the whole room quickly. This observation can be explained as follows. The burning of incense stick produces gases, having pleasant smell. The particles of gases produced by the burning of incense stick move rapidly in all directions, mix with the moving particles of air in the room, and reach every part of the room quickly. So, the observation that the fragrance of a burning incense stick spreads in the entire room very quickly tells us that the particles of matter are constantly moving. The particles of matter attract each other. The next characteristics of matter is that the particles of matter attract each other. There are some forces of attraction between the particles of matter which bind them together. The force of attraction between the particles of the same substance is known as cohesion. The force of attraction is different in the particles of different kinds of matter. If we take a piece of chalk, a cube of ice, and an iron nail and beat them with a hammer, we will find that it is very easy to break the piece of chalk into smaller particles. It requires more force to break a cube of ice, whereas the iron nail does not break at all, even with a large force. This shows that the force of attraction between the particles of chalk is quite weak. The force of attraction between the particles of ice is a bit stronger, whereas the force of attraction between the particles of iron nail is very, very strong. This is an actual chrome alum crystal. It is a solid. The force of attraction between the particles of chrome alum is large. This is the model of chrome alum crystal showing the arrangement of particles in it. These particles attract one another with a large force. Diffusion. In this section, we will learn about the diffusion in solid, liquid, and gases. Introduction. The spreading out and mixing of a substance with another substance is due to the motion of its particles is called diffusion. The diffusion of one substance into another substance goes on until a uniform mixture is formed. Diffusion is a property of matter which is based on the motion of its particles. Diffusion occurs in gases, liquids, and solids. Diffusion fastest in gases and slowest in solids. The diffusion is fastest in gas because the particles of gases move very rapidly. The diffusion is slowest in solids because the particles in solids do not have much space. The diffusion in liquids is, however, much faster than that in solids. The rate of diffusion increases on increasing the temperature of the diffusing substance. The phenomenon of diffusion tells us that the particles of matter are constantly moving. Diffusion in gases. So now we learn about the diffusion in gases. Diffusion in gases is very fast. This is because the particles in gases move very quickly in all directions. The rate of diffusion of a gas, however, depends on its density. Light gases diffuse faster than heavy gases. The smell of food being cooked in the kitchen reaches us even from a considerable distance. This can be explained as follows. When a food is cooked, some of the substances in food releases gases having the smell of food in them. The particles of these gases move very quickly and mix up with air by diffusion. When the air containing these gases reaches our nose, we get the smell of food being cooked in the kitchen. Thus, the smell of food being cooked reaches us even from a considerable distance by the process of diffusion. See some other examples. When we light an incense stick, in a corner of our room, its fragrance spreads in the whole room very quickly. The fragrance of burning incense stick spreads all around due to the diffusion of its smoke into the air. Diffusion in liquids. Diffusion in liquids is slower than that in gases. This is because the particles in liquids move slowly as compared to the particles in gases. Here are some examples. If a crystal of potassium permanganate is placed at the bottom of water in a beaker, then the purple color of potassium permanganate spreads into the whole water slowly. The spreading of purple color of potassium permanganate into water on its own is due to the diffusion of potassium permanganate particles into water. And if we pour a drop of ink into a beaker of water, then the color of ink spreads into the whole water of the beaker. The spreading of ink in water on its own is due to the diffusion of ink particles into water. Diffusion in solids. Diffusion can also take place in solids. Diffusion in solids is very slow process. We will now give two examples of diffusion of solids in solids. Number 1. If we write something on a blackboard and leave it uncleaned for a considerable period of time, we will find that it becomes quite difficult to clean the blackboard afterwards. This is due to the fact that some of the particles of chalk having diffused into the surface of blackboard. Number 2. If two metal blocks are bound together tightly and kept undisturbed for a few years, then the particles of one metal are found to have diffused into the other metal. The diffusion of a solid substance into another solid substance is so slow that many people think that diffusion does not take place in solid at all. Change of state of matter. Matter can exist in three physical states: solid states, liquid states, and gaseous states. For example, water exists as a solid in the form of ice, as a liquid in the form of water, and as a gas in the form of steam or water vapor. We can change the physical state of matter in two ways: by changing the temperature and by changing the pressure. Solid to liquid change. Melting. The process in which a solid substance changes into a liquid on heating is called melting or fusion. So, when ice changes into water on heating, it is called melting of ice or fusion of ice. A change of state takes place during melting. The melting of a solid substance takes place at a fixed temperature. So, the temperature at which a solid substance melts and changes into a liquid at atmospheric pressure is called melting point of the substance. Different solids have different melting point. For example, the melting point of ice is 0 degrees Celsius. The melting point of wax is 63 degrees Celsius, whereas the melting point of iron is 1535 degrees Celsius. When a solid substance is heated, the heat energy makes its particles vibrate more vigorously. At the melting point, the particles of a solid have sufficient kinetic energy to overcome the strong forces of attraction holding them in fixed position and break to form small groups of particles, and the solid melts to form a liquid.